Hello everyone, I welcome you all to the mathematics class. My name is Gafaru Idowu Akonji. The topic we want to discuss today is factors and multiples. And if you can recall very well, we started this topic by talking about factor. What does a factor mean? And in that session then, we also listed some factors. And I think I gave out assignment to students on finding factors of some numbers. But today we want to progress with that. And the aspect of it which we are going to talk about today is the one that has to do with prime number and prime factor. That is the first subtopic we want to talk about today. By the word prime number, it simply means a number that has only two factors, one and itself. So it might be necessary I put down the definition. So prime number or numbers is or are numbers that has or have two factors, one and itself, e.g. 2, 3, 5, 7, 11, and the list continue till infinity. Now, what the definition talks about is this: anything called number or anything called prime number or prime numbers is a number that has only two factors. And remember what the word factor there is going to mean. It means that only two numbers will be able to divide such a number, and the two numbers that will be able to divide it are that one and that number itself. Now, if we compare it to what we treated under factors, so you can remember I said to any number we have two extreme factors. So the lower extreme factor as well as the upper extreme factor. The lower extreme factor is the lowest possible number that can divide such a number, while the upper extreme number or extreme factor is the number that can divide the highest number that can divide such a number. And such number is that number itself. So the lower extreme number is 1, while the higher extreme number is what? Is that number itself. So it is from that notion that the concept of prime number was derived. So it means it is a number that in its lifetime only two numbers will be able to divide it. So that is the reason why it was stated in the definition that it has two factors. That is, it has two factors there means only two numbers will be able to divide it, and those two numbers are the extreme divisor the number has. So remember, those extreme factors are 1, the lowest one, and that number itself, which is the highest of all the numbers that can divide it. So that is what the definition of what prime number talks about. So which means if you have a number that has any other number that can divide it other than those two extreme values, such a number is not going to be treated as a prime number. So it's rather going to be named any other number forms or any other forms of number rather than being referred to as what? As a prime number. And we can see we have some example here: 2, 3, 5, 7, 11, and so on are prime number. Now, what we are going to do now is to test, to check whether some numbers are qualified to be called a prime number or not. So in the example 1 now, example 1, check if each, name the prime, let me put it this way, name the prime numbers among the following numbers. So I have 8, I have 3, and I have 29. Now the first one I have, so the solutions, so the first number I have here is 8. For me to be able to detect whether 8 is a prime number or not simply means that what, I will go and list all the possible numbers that can divide it. Now if it has only 2 numbers that can divide it, so it is going to be named only 2 numbers, so it is going to be named as what, that is, we are going to regard it as a prime number. But if it has more than 2 numbers that can divide it, then it's no longer going to be a prime number, but can fall under other forms of what, of numbers. Now checking it, you can start with the lowest possible number that can divide any number, that is 1. 1 should be able to go in any number. Now when we observe 8 very well, we can see that 2 can as well divide it, so this is another factor of 8. Now 3, what about 3? And remember what we mean by the number that can divide it are those numbers that when we use them to divide this thing, it will leave no remainder, or it leaves a remainder of 0. So when we apply the next number, we have 3. So how many 3 can we get in 8? You can see that is 2 with the remainder of 2. So 3 is not a factor at all. Now let's make use of the next number, that is 4. Can 4 divide 8? Yes. 4 in 8 gives 2 with the remainder of 0. 4 is another factor of 8. Now 5, 6, 7 are not factors of 8, because whenever each of those 3 numbers divided 8, they are going to leave a remainder. Now the last number that can divide it is what? Is 8 itself. So for me now to check or to determine whether this thing is a prime number simply means I'm going to consider how many numbers can divide it. That is, how many factors does the number 8 has. So since the amount of factors it has is more than 2, then 8 is not a prime number. So I can say that what? I can say that 8 is what? Not a prime number. So that is number 1. Now in number 2, the number I have there is 3. Now let us check. Now the minimum number that can divide 3, we know it is 1. So the next number we can make use of is 2. Can 2 divide 3? So we know when 2 goes in 3, it leaves a remainder of 1. So as a result of that, we are going to treat 2 is not going to be a factor of 3. And the last number that can divide it is 3, because 3 divided by 3 gives 1 with the remainder of what? Of 0. So 3 can divide 3. I remember I told you the other time that the maximum number that can divide any number, or the maximum factor any number has, is that number itself. So as soon as we are able to divide by that number itself, that means we are done with its factor. So these are all factors that 3 has. So when we look at this thing very well, we are going to see that it has just 2 factors. And the 2 factors it has are what? 1 and what? That number itself. And that is what the definition is talking about. That what we call a prime number is a number that has 2 factors, 1 and itself. And we can see in this case that only 2 numbers can divide 3, and those numbers are 1 and itself. And as a result of this, we are going to say that what? 3 is a prime number. Now number 3 here, what I have there is 29. Now let us check 29 very well. So we are going to start by way of what? Listing its factors as well. So we know the minimum number that can divide any number is 1. So 2, 3, any other number cannot divide this 29 except 29 itself. Because I don't want to take much of our time on this, so it is part of what we've done. So what we are going to do in order for us to know whether any number is a prime number or not is that we should be able to list all the factors such a number has. But in this case, only 2 numbers, only 1 and 29 are those numbers that can divide 29. And as a result, 29 as well is what? We say that 29 is a prime number. So it is also a prime number. So that is one of the first things we want to talk about. Now the next thing that is of importance to us is how do we express. So that one involves solving some questions. So we might be asked. So let's take that one by example. Example 2. Express age of the following. Express each of the following as a product of prime factors. So number 1, 36. Number 2, 210. Number 3, 2700. Number 4, 60. And number 5, 2310. So solutions now. So in number 1, the number I have here is 36. Now, for me to express any number as product of its prime factors, what that means is we want to rewrite this number in such a way that it is something times something that will give us that number. But those elements that will multiply together to produce this number are prime numbers. So that is, they are prime factors. Those numbers that can divide this thing that happens to the what? To the list of prime factors. That is, we want to write 36 making use of what? Making use of the product of its prime factors. So what we are going to do in that case is we want to first of all slice this number. That is, we want to divide it until it becomes 1. So when we are able to do that, then we'll now be able to list those prime factors. So that's going to be 36. I will divide this number until it becomes what? 1. And when it comes to division, the smallest number we can use in this case is what? 2. It's not that I can't use or I can apply 1, but when one divides 36, no, it still gives 36, which makes no meaning of sense. So we rather make use of 2 here. 2 in 36 here gives what? 18. 2 in 18 here gives 9. 3 in 9 here gives 3. And 3 in 3 here gives 1. And remember that our first objective here is to ensure this number becomes 1. So once it becomes 1, you can now say that therefore our 36 is equal to, we are not going to state it in product term, that is, we are going to multiply all these numbers we use to what? To reduce it to 1. So 36 is now going to become 2 times 2 times 3 times 0. So which means to express this number as product of its prime factors, so the result we are going to have is this. So then let's move ahead to number 2. In number 2, the number given to me there is 210. So you know what we are going to do initially is to reduce this number to 1. So we know 2 can divide 210. 2 in 2 here 1, 2 in 1 here 0, then 2 in 10 here is 5. Then the next number that can divide this is 3. 3 in 10 here gives 3. 3 in 15 here gives 5. So we know 5 can divide it next. 5 in 35, 7. And 7 in 7 is what? 1. So we can now say that therefore 210 as given to us in the question is the same thing as 2 times 3 times 5 times 7. So in number 3, what I have there is 2700. 2700. So remember, we also want it to become 1. So the division can begin with 2. 2 in 2 here gives 1. 2 in 7 here gives 3. Remaining 1. 2 in 10 here is 5. 2 in 0 here is 0. I can use 2 again. 2 in 13 here is 6. 2 in 15 here is 7. While 2 in 10 here gives what? 5. Now we can make use of 3 now. So 3 in 6 here gives 2. 3 in 7 here gives 2 with the remainder of 1. And 3 in 15 here is what? 5. So 3 can still divide. 3 in 22 here is 7. 3 in 15 here gives what? 5. So 3 in 7 here 2. 3 in 15 here 5. And the next number that can divide this is what? 5. So 5 in 25 here gives 5. And 5 in 5 finally gives 5. So we can now say that therefore 2700 can as well be written as 2 times 2. 1, 2, 3 times 3 times 3 times 3 times what? Times 5. Then in number 4 and number 5 as given above, let me rather give that one out to us as what? As a kind of class work. So 4 and 5, should be our class work. The 2 should be the class work. Now the next aspect of our factors we want to talk about is the concept of HCF, which is commonly known as what? The highest common factor. Now what the word HCF means is, out of all the factors that a number has, we want to pick the higher of those factors. That is the biggest out of all the factors any set of numbers can have. So that is what the notion of what HCF talks about. Now we are going to take example for us to fully understand that. So find, okay, let me see example 3 here. Find the HCF of each of the following. Number 1, that is 15 and 40. Number 2, 24, 30 and 36. Number 3 there, 96, 120 and 144. Now solutions now. So number 1, there are 2 approaches to dealing with our HCF. So I'm going to divide my book into 2. This first column here, I will use it for the method 1, while the second column here will be used for the second method. So both give the same result. Now under the first method, what we're going to do is I'm going to pick each number separately and make sure they are reduced to 1. So when I have my 15, my aim here is to make it 1. So the number that can divide 15 here is 3. 3 in 15 here gives 5. Then 5 in 5 here gives what? 1. Then the other number will also be picked. Then with the aim of also making it 1. So 2 in 40 here gives 20. 2 in 20 here gives 10. 2 in 10 here gives 5. And 5 in 5 here gives 1. So we can now say that the HCF here is equal to, not that. Now let me continue here. Now it means that the first number given to me is 15. So I can say my 15 here is 3 times 5. While the other number 40 here is what? 2 times 2 times 2 times 5. Now what we want to do now is we want to pick the highest factors that we have in here. Or simply what we can do is we want to pick the numbers that are common to both the first number as well as the second one. So I can see 3 is here, but I don't have it here. So 3 is not going to be picked. I have 5 here and I have it here as well. So that one is going to be picked. So there is no other number that is common to the 2. So therefore, the HCF of the number we are asked to find, that is 15 and 40, is what? 5. Under the second method, so we can, when we observe this one, we can see that our division, we did it separately. So in the other method, what we are going to do is we are going to combine it together. So in this form, 15, 40, I'm going to cut in this way. So but what will happen here is I will continue dividing as long as I have number common to the 2. As soon as there is no number common to the 2, that's going to be my stopping point. So which means any number we are going to use to carry out our division here must be a number that can divide both at the same time. So we can see 2 can divide this but cannot divide this. So 2 is not going to be used. The next number we can use is 3. 3 can divide this but 3 cannot divide this. We will not use it. The next number we can use is 4. 4 can divide this but because it cannot divide this, 4 is not going to be used at all. Then the next number we can use is 5. We can see 5 can divide this, 5 can divide this. So in that case, 5 will be used. So 5 in 15 here gives 3 and 5 in 40 here gives 8. Now when we consider the 2 numbers we have here, that is this 3 and 8, you can see that there is no number common to the 2. No number can divide this as well as this again. So it shows that we are done. So in that case, we are going to say that the HCF here is equal to what? The HCF here is equal to 5. Then the next one is our example 2. In number 2, what I have there is to find the HCF of 24, 30 and 36. So I can apply the second method here, 24, 30, 36, because it's a kind of it doesn't waste time. So we can see 2 can divide this as well as this, so 2 will be used here. 2 in 24 here is 12, 2 in 30 here 15, and 2 in 15 in 36 here gives what? 18. So we can see that 2 can divide this, it can divide this, but because it cannot divide this, 2 is not going to be used. Now let us make use of 3. 3 can divide this, it can divide this, it can divide this, so 3 will be used. 3 in 12 here gives 4, 3 in 15 here gives 5, 3 in 18 here gives 6. Now we can see that there is no number that can divide this and this again, so it shows that the HCF of 24, 30 and 36 is equal to 2 times 3, which is equal to 6. So the result there is what? 6. In number 3, what I have is 96, 120 and 144. So the aim of what? Reducing everything here to 1 as well. So we know 2 is common to everything. 2 in 9 here is 4, 2 in 16 here is 8, 2 in 12 here is 6, 2 in 0 here is 0, 2 in 14 here is 7, and 2 in 4 here is what? 2. 2 can go as well. 2 in 4 here 2, in 8 here 4, in 60 here gives 30, in 72 here gives what? 36. 2 is still able to divide here. 2 in 24 here gives 12, 2 in 30 here is 15, and 2 in 36 here is what? 18. So we can see that 2 can divide this, it can divide this, but it cannot divide this, so 2 will not be used again. Now the next number that can divide everything at the same time is what? 3. So 3 in 12, 3 can go this, 3 can go here, so I'll make use of 3. 3 in 12 here gives 4, 3 in 15 here gives 5, and 3 in 18 here gives what? 6. So when we observe this thing very well, so we can see that none of this number has any common factor, and as a result this is going to be our stopping point. So I will now say that HCF of 96, 120 and 144 is equal to 2 times 2 times 2 times 3, and that becomes 2 times 2 here is 4, 4 times 2 here is 8, 8 times 3 here is 24. So that is HCF. And I want us all to remember that there are 2 ways or approaches to finding the HCF of any number. The first approach is when we carry out our division individually, and the other approach is when we combine them together. In the case of dividing them individually, our aim is to make sure every number we have becomes 1. But in the situation of the second method, what we want to do there is that we want to divide as long as those numbers given to us still have a given number common to them. And whatever result we get at the end of the day, that is those number which was used to carry out the division has to be multiplied together so as to what? Arrive at the what? The required result. And finally today, in today's class, is the concept of the lowest common multiple. Now, so I'm also going to treat that one by way of what? Example. So the last example, example 4. So we are asked to find the LCM of the following. So number 1, 30 and 45. Number 2, 24, 30 and 36. Now let's make it the 2 examples. So solutions now. So number 1. So what we are going to do here is we are going to write out the numbers as given here, and we are going to divide the number. So the division has to be at the same time. But the difference between this one compared to the one of the HCF is that the division will stop as long as we don't have anything common as long as we don't have a common factor again. But in the case of finding the LCM, the way this division is going to be carried out is that we are going to divide until each number be reduced to 1. So let's start with the lowest number that can divide this in, that is 2. 2 in 30 here gives 15. So 2 can't divide 45. We know it's going to leave a remainder. So we'll rather leave 45 as 45. Now the next number we can make use of is 3. 3 in 15 here gives what? 5. 3 in 4 here is 1. While 3 in 15 here gives what? 5. You know 3 can still divide because 3 can divide 15 but not 5. Since it can't divide 5, we are going to write 5 as what? As 5. And 3 in 15 here gives what? 5. And we know the final number we can use for our division here is 5. 5 in 5 here is 1. 5 in 5 here is 1. So that was the reason why I said in the case of LCM division, we are going to divide until each number given to us changes to 1 or becomes what? 1. So we are now going to say that LCM of 30 and 45 is equal to the numbers with which the division was carried out. So 2 times 3 times 3 times 5. So we know 2 times 3 gives 6. 6 times 3 gives 18, and 18 times 5, that is 90. 18 multiplied by 5. 8 times 5, 40. 5 times 1, 9, so 90. So that gives the result of what? 90. So the LCM of 30 and 45 is 90. And finally, we want to discuss the second question. So in number 2, we are also asked to find the LCM of 24, 30 and 36. 24, 30, 36. Remember, our aim is to reduce each number we have here to 1. Now 2 in 24 gives 12. 2 in 30 is 15. 2 in 36 is 18. 2 in 12 gives 6. Since 2 cannot divide 15, we rather write it as 15. 2 in 18 here gives what? 9. 2 can still divide 6 but can't divide other, so we are going to settle that case first. So 2 in 6 here gives 3. So since it can divide 15 as well as 9, we are going to write them the way they are. Then the next number we are going to make use of is 3. 3 in 3 here is 1. 3 in 15, 5. 3 in 9 here is 3. We make use of 3 once again. You know 3 can divide 1. 1 will be written as 1. 3 can divide 5. 5 will be written as 5. While 3 in 3 gives what? 1. And the final number we are going to make use of is what? 5. So 5 can divide 1, we write that as 1. But 5 in 5 here gives 1. 5 can divide 1, we write this as 1. So we can see that every number given here has been reduced to what? To 1. So we're now going to say that the LCM of 24, 30 and 36 is equal to 2 times 2 times 2 times 3 times 3 times 5. And that gives 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. We can say 84 times 3 times 5 here is what? 15. So the multiplication can be done here. 5 times 4 is 20. 5 times 2, 10. Plus that 2, 12. 1 times 4, 4. 1 times 2, 2. Here I have 0, 6, 3. So the result that gives is what? 360. So and that finally give the result of finding the LCM of 24, 30 and 36. So I will call this class, I will call it a day in this class. But before I call it a day, I think it's going to be necessary for me to also leave the student with some assignments. So number 1, find the LCM of 24, 36 and 50. Number 2, find the HCF of 24, 36 and 50. Number 3, list all the prime factors between 1 and 50. Number 4, what is a prime number. And number 5, list all the factors of one